So hello friends, welcome to Inspire Chemistry. Today in this video we will be talking about one important name reaction or rearrangement, that is benzyl-benzilic acid rearrangement. Okay, so this rearrangement is very important for your exam point of view and for your also MSc or BSc degree course. Okay, so in this rearrangement we will see that the diketone will form acid beta hydroxy acid. Okay, so this is very important for your exam point of view and also for your industrial purpose. Okay, so you can form different type of product by this rearrangement. So let's start the video. At first, benzyl-benzilic acid rearrangement. What is benzyl? Okay, so pH CO this is called benzyl. Okay, this is also like this. Okay, so at first this type of diketone is taken, and after that they are this OH or OMe, different type of base, maximum case OH, KOH, NaOH, hydroxy. Okay, different type of hydroxy base, that is KOH, NaOH, strong base are used here. So here this base will attack this side or this side, because this carbonyl center, that is keto center, is very electrophilic. It want to nucleophilic attack. So this will attack this side or this side, because these are this side, two sides are equivalent. Okay, in this case, so when it attack, this will release. Okay, so I just write like pH C double bond O C O negative and pH, and here OH. Okay, this is formed. After that, this, in this case, one rearrangement takes place. That is, what type of rearrangement? In this case, this pH will migrate to this carbonyl group. Okay, migrate this carbonyl group, and at that time this released double bond O bond will get back to its position, and what will form here? pH C pH. So when it will attack this will release O negative, and here double bond O and OH. Okay, this will release. Okay, and after that, when we give H plus or any water, mild acidic water, it will protonate and form OH, that is pH OH, and here OH. Okay, so this type of product is formed here. So this is called beta hydroxy, that is alpha hydroxy acid. So here it is alpha carbon, here alpha carbon, alpha hydroxy. Okay, so this type of product is formed in this benzyl-benzilic acid rearrangement. So this mechanism is very important. At first we take this type of diketone, and when we use different type of base like OH minus, most of the cases, this will attack this electrophilic carbon center, and for this oxygen bond will release, and like this. After that, a rearrangement takes place. Okay, rearrangement takes place. This pH migrate to this carbon center. Okay, when it migrate, this released bond get back to its position, and this double bond O release. This type of intermediate will form, and after that, when we use mild acidic water, it will be protonated, and this type of hydroxy acid forms. Okay, this will be the product. So this reaction is very important, because from this diketone we can form hydroxy acid. This is very important for your exam, and most of the cases it is very important for industrial purpose. Okay, so I have some example also for this reaction. Okay, so practice this mechanism because it is very important for your exam point of view also. So when you see that one diketone is the substrate and their base is OH minus in most of the cases, then and after that protonation will take place, then you will do this mechanism, benzil-benzillic acid. Okay, so here one question, I have one example also, that is okay, OH minus. So here we see that here two carbonyl group di-keto group. So here two C double bond O carbon is present, carbons are present. So here we see that this and this, among this which is more electrophile. Okay, this which will be more electrophile in this carbon OH will attack. We see that here pH and here OMe. pH also have plus R effect. Okay, and it is also have plus R effect. We know that when pH at the para position OMe group is present, this plus R effect will be very much. That is OMe very much greater than pH. That these have more plus R effect than this. So as it has more plus R effect, it will release its electron. Okay, and this will like this. So here OMe, for this OMe group, here electrophilicity of this carbon decreases. So here OH minus cannot attack this side because this is more electrophile. Okay, so this OH minus will attack this carbon, this will release. Okay, so after that OMe C double bond O, C O negative. Okay, pH and OH. And now we see that here migration take place, migration of the pH to this carbon center, O minus will get back to its position, and like this OMe, okay, C pH, this will released here. Okay, and this carbon and C double bond O, OH like this. And after that when we use H3O plus, that is mild oxidized, mild acidic water, then this O minus take the proton and forms like this. Okay, and this is acid. This will be the product. Here one hydroxyacid form. In this case the main thing is that here two carbonyl groups are present, but in this case we have to determine that these two carbon between these which is more electrophilic. But in this case we see that here OMe group phenyl with para position OMe group, and another side pH group only phenyl group is present. We know that pH group has plus R effect, but this phenyl at the para position OMe, it has more plus R effect than the pH. So at for this this lone pair of electron goes to the resonance with the benzene ring, and here the double bond will be the conjugation with the carbonyl carbon. Okay, so it is more electrophilic, less electrophilic. So this OH minus will attack this carbon, and after that this type of intermediate will form, and this pH will go to the this carbon center and migrate to this carbon, and this type of product is formed. And after that H3O plus when we give, then O minus take the H plus and form this type of hydroxy acid. This will be the product. Okay, so Now we will discuss also two important questions that is very important for your exam point of view. Okay. The first question is that this substrate, we have this substrate, okay, and at the first KOH is used, okay, KOH, and in the second H3O plus. So what will be the product? So we see that here diketone is present and OH minus base is also present. So here we, without any complication, we just write the benzyl-benzillic acid rearrangement. Okay, so at first this substrate and OH minus, okay, it will attack this carbon and this will release. Okay, so what will form here? O negative and OH. Okay, after that here this bond will migrate. One migrates up. At first OH minus will attack, then bond migration, and after that this oxygen will get back to its position and this double bond oxygen will release. These are the steps of this benzyl-benzillic acid rearrangement. So what will form here? This. Okay, so here and I have O negative. This type of, this is formed. Okay, so now we give the H3O plus here, so this will be protonated and form like this, COOH, and this is OH. This is the product. Okay, so at first this type of diketone will is attacked by this OH minus. After that this double bond O will release and this bond will migrate to this double bond O, okay, carbon center, and this released oxygen bond get back to its position and this will release. After that this type of intermediate will form and H3O plus, when we use this will protonated and this type of acid, hydroxy acid, will form. Another big example is present also. This is very important for your exam point of view. Okay, just note down these examples and practice this mechanism, because this mechanism is also important for your exam point of view. Okay, without this mechanism you cannot get the product properly. Okay, so next question is, okay, this type of substrate, after that KOH, sorry, at first not KOH, at first K2Cr2O7 and H2SO4 concentrated, this will form A. After that KOH and second H3O plus will form B. Okay, this is the question. So we know that K2Cr2O7 in presence of high concentrated H2SO4 is very oxidizing agent. Okay, so it will oxidize this double bond. Okay, because in this case these double bonds are not oxidized, because in this case these two benzene ring is very stable. Okay, so these two center are very reactive in these cases. This is phenanthrene. Okay, so at first when we use K2Cr2O7 and K2Cr2O7 or H2SO4 concentrated, so this will oxidize, but the oxidation product will be okay, oxidized product will be like this. This will be the oxidized product. Okay. After that, we see that here diketone is formed, and then we use KOH. This OH minus these two carbonyl center are same. Okay. So any of them will attacked by OH minus. I just write here. This type of product. Okay. OH, this will be the double bond O. Okay, so these bond migrate, this will release to its position. What will form? Sorry. COOH and O negative. After that we use H plus or H3O plus here, so it will form okay. This will be the product. Okay, so in this reaction we will see that this type of substrate is used, and when we use K2Cr2O7 and H2SO4 concentrated, this is oxidizing, high oxidizing agent, and we know that also for phenol 3 these two position is very reactive for the reaction. So this will oxidize and form like this type of two diketone intermediate. Okay, A. And after that, when we use KOH, this OH minus will attack any of them because these two carbonyl center are same, and so this type of intermediate, tetrahedral intermediate will form, and this oxygen will release and this bond migrate to this carbon. So this type of form is formed. Okay, and after that H plus, when we used mild acidic water or H plus, then this will protonated and this type of product is formed. So this will A and this is the B. Okay, so that's all for today's video. This benzil-benzillic acid rearrangement is very important for you, for your exam point of view, because it is very important for NET, GATE or JAM, and also for industrial purpose. So please practice this exam question mechanism, and these three questions which I have discussed is very important for your exam point of view. Please follow our channel. If you get any information from our video, please hit the like button, subscribe our channel and share it with your friends. Thank you for watching. See you in the next video.